Okay, good evening, everybody. From a warm, calm, beautiful evening in Eastern California in the Death Valley region, my name is Mike Jerry, and we're going to look at some pretty cool astronomical objects tonight. As I indicated in my communication, we're going to be doing the Cloudy Nights May Observers Challenge. And it's going to be a mix of some interesting Messier objects and some other NGC objects. So it's going to be kind of a fun thing to do. And then we got a couple challenge ones too. Not a long list tonight, but that's okay. Our last list was pretty long, so this one will just, if we get done with an early night, I'm probably okay with that anyway. But yeah, so let me refresh this over here and make sure that's going. Yeah, okay, good. And good, that's also muted. Super. Okay, so let me start off. Actually, I forgot to bring up my there it is. Forgot to bring up my setup. I really should start with this every time. And let me also get rid of the test pattern so you guys can actually see what I'm seeing. Twink. Okay, there we go. So this is my setup, and we'll go to the important part here, which is a 6-inch imaging Newtonian, a simple reflector telescope. And here is the eyepiece holder, the focuser, into which I put a camera. And that camera then connects directly to this laptop over here on the table. And that's how I'm sending you all these pictures. So all of that is riding on a Celestron Evolution mount, which is right there. And then that is riding on a Celestron HD Wedge, which keeps the entire thing polar aligned so that it rotates very precisely around the northern celestial pole, and allows tracking to be very accurate when we're taking our exposures, because we're holding our camera open for most of the time 60-second exposures, and so this allows the mount to really follow things very accurately so we don't get smeared or streaked stars, hopefully. And all of that, of course, is on my spare no expense cinder block pier here, which is all glued together with construction adhesive, and comes with these very handy storage pockets at no extra charge, and just works great. So the cinder blocks and the wedge stay outside all the time, permanently polar aligned, which saves me a lot of time at setup, because getting things precisely polar aligned takes a lot of time. And so that just helps me out a lot to get things set up. But in the meantime, let's get started on our objects. Let's see, what am I on right now? I'm still on Regulus, so that was the star that I used to align and focus. And so M67 is actually right here. So let's just send the scope over there. And look at a nice big globular cluster. Okay, and I forgot to do next target, which will significantly increase the contrast. And let me see. Oh yeah, boing, right there. Okay, good. Now this normally, when I start imaging, I have it set to do a 60-second exposure, which is way too much for a big bright globular cluster. So I'm going to interrupt that and go with maybe a 15-second exposure, because that will be probably a lot more helpful for a... let me clear this. I'm not sure what I got there. Let me clear that out. And the first one will come in, and then we will do an auto stretch, which should have things looking a bit better. And this will be our nice big bright globular cluster. Yeah. So let's see. Most globular clusters are outside the plane of our galaxy. Here's 67. And the theory is with these globular clusters that they are probably they're smaller captured galaxies that have been captured in the gravity well of the Milky Way and have had their outer extremities stripped away, and all that's left is the cores of the stars that they had in them. So some of them have hundreds of thousands of stars, and they're really kind of spectacular objects. So this is an open cluster in the southern equatorial half of Cancer. It was discovered by Johann Gottfried Kohler in 1779. Estimates of its range are between 3 and 5 billion years. Distance are likewise varied, typically 800 to 900, 2600 to 2900 light years away. So that's pretty darn close, actually, to us. Estimates they were established using a binary star. It's not the oldest known open cluster, but clusters known to be older tied to the Milky Way are few, and none of those are closer. It's a paradigm study object in stellar evolution. It's well populated, has negligible amounts of dust to obscure its stars. All its stars are the same distance and age, save for approximately 30 anomalous blue stragglers. However, generally products of mass transfer in binaries or stellar collisions. So, being generally the products of stellar collisions. So most of the stars are somewhere in that 3 to 5 billion year age range, and they it's actually 2,500 to 3,000 light years away. So that's actually pretty darn close. Cluster is known to be older. It's not the oldest one, but it's one of the oldest known clusters. But they are saying it's tied to the Milky Way, so it's definitely considered to be some sort of captured object, like perhaps a stellar, another galaxy. M67, one of the most studied open clusters, yet estimates of its physical parameters, such as age, mass, and number of stars of a given type, vary substantially. Its mass is about 1,100 solar masses, and number its white dwarfs at 150. It has more than 100 stars similar to the Sun, which makes sense because our Sun is about 5 billion years old right now, and has numerous red giants. Total star count has been estimated at well over 500. The ages and prevalence of Sun-like stars had led some astronomers to theorize it as the possible parent cluster of the Sun. However, computer simulations have suggested that this is highly unlikely. Cool. So, interesting little cluster there. Good evening, Jeff. Clouds, yeah. Well, we out here in the desert, clouds are typically not our biggest bugaboo. Our biggest bugaboo usually is wind, and actually that has kept me from having a live stream at least last night. I think 2 nights ago was, but yeah, at least the last couple of nights. The skies have been beautiful and clear, but when you're in the wide open like this, and there's not a lot of humidity, you don't have any trees, and you don't have stuff that can knock the breeze down. So we just get a lot of breeziness here, and well, that makes it really challenging when you're trying to do imaging and you're holding that camera shutter open for 15 seconds or 30 seconds or 60 seconds as I do. So it makes things a wee bit challenging. But that's a pretty nice. So they're estimating about 500 stars in this. That's pretty cool. In fact, I know one thing I forgot to do. Actually, I forgot to do a couple things. I forgot to do my enhancements here, which sharpen the image up nicely. And I also forgot to do a color balance. Woo! That certainly got it blue. I got it way too blue. Am I blue? Am I blue? Okay, it's starting to get a little bit better. Anyway, most of these stars are going to be the same color because most of them are the age and seem to be about the majority of them are like our sun, which is why they were saying that the original theory of this cluster was that they thought this was where our sun was actually born, but it doesn't look like that's the case. But these are all very similar stars. There are red giants in here, and there are a few blue stragglers, they call them, but about 500 stars in this one cluster. Often better to often best to see these in their full context of all the surrounding stars. Most of these stars will be closer to us than this cluster. In fact, most globular clusters are outside of the plane of the Milky Way galaxy, which lends credence to the theory that they're actually other captured galaxies that orbit the Milky Way. This one is less than 3,000 light years away, though, so that's pretty close. That may not be very far out of the plane at all. But cool. Okay. That's a pretty good one. Let's go to the next thing. Nice thing about globs is that they don't have to spend a whole lot of time on them, because they come in pretty fast and sharp. Okay, M101 is next. That's going to be up north, near the Big Dipper. M101. Yeah, right under, so it's under the handle. It's under the handle of the, so there's the upside down Big Dipper right there, as it is this time of year. And so it's this galaxy right there. The pinwheel. And for this, my scope does some gyrations and it actually flips upside down to achieve this. And so the only unfortunate thing of that is that sometimes that changes the focus. So we'll have to see how this looks. Well, there it is, definitely right there. Focus doesn't look too bad. Stars don't look too bad. Alright, well, let's just see what we can see. If I have to refocus, it just takes a minute to do it. But the Pinwheel Galaxy. A fun one. Let's get the red patch here. Determines the size of my field of view of my camera based on the sensor size. Actually, that's the 183. We're using the color one tonight, which is a square sensor. So it should fit in there really nice. So we'll see what comes up here. See what the live image gets us. In the meantime, we can look up and see what the Pinwheel Galaxy is. A face-on spiral 21 million light years away from Earth in Ursa Major. It was discovered by Pierre Marchand in 1781 and was communicated that year to Charles Messier, who verified its position for inclusion in his catalog as one of its final entries. Yeah, 101. He only did 103 objects in total, so. And because we're doing a 60-second exposure, this needs to be adjusted quite a bit. Yeah, but that's not looking too shabby there. Maybe just a little too much blue. Yeah, that's looking pretty good. See how much of that we can bring in with the color camera. Galaxies definitely do look better with the mono, but They're certainly pretty in the color too, and this is a fairly big, bright one, so the color camera will do better with this than most of the little tiny galaxies that I tend to shoot. So but this should start looking better and better as it comes in. Okay. So it's 21 million light years away, so we're seeing this as it looked 21 million years ago. On February 28th, 2006, NASA and the European Space Agency released a very detailed image of it, which was the largest and most detailed image of a galaxy by Hubble, the Hubble Space Telescope at the time. The image was composed of 51 individual exposures, plus some extra ground-based photos. Let's see, what else did they have to say? Anything? It's a large galaxy with a diameter of 170,000 light years, so that's much bigger than our own Milky Way, which is estimated to be somewhere in the 100 to 120,000 range, so it's significantly larger. It has around 1 trillion stars, which is twice the number that we have in our Milky Way. It has a disk mass on the order of 100 billion solar masses, along with a small central bulge of about 3 billion solar masses. 3 billion solar masses. Its characteristics can be compared to those of the Andromeda Galaxy. And then they talk about the chemical composition of the stars, which is, you know, somewhat interesting to some people, but not to most. M101 is asymmetrical due to the tidal forces from interactions with its companion galaxies. So we can see at the top here, it's kind of this arm has been kind of pulled away a bit. It's nice and round down here, but it looks like there's another galaxy here, and the focus is a little soft, so we don't have a whole lot of there's a little bit of detail loss with it, but I think it's okay without me having to refocus. So they're saying that it's been pulled out of shape by the galaxies that are in the area that are probably orbiting it, or that it has as companions somewhere around it. I forgot to turn on my music, so I'll do that. Get that music going. The gravitational interactions compress interstellar hydrogen gas, which then triggers strong star formation activity in M101's spiral arms that can be detected in ultraviolet images. Yeah, you can see in almost any of these clumps. Whoops, look at that, photobombed. Right through the middle of the galaxy. But most of these pockets, these brighter pockets, tend to be areas of high energy, which are probably star formation. Especially if they're bluish or reddish in color. Well, I'm not going to start the stack over again for one satellite, but well, it is a pretty galaxy though, so maybe I will. Only 10 seconds away from the next one anyway, so I think I will. We'll just nuke that, see if we can get a good clear one without the satellite through it. Hopefully it's not the Starlink chain where I'll have more coming through. Those have been going over the last 2 or 3 nights out here. The whole train of satellites all in a row, just zipping overhead. Yeah, we did get bisected there, but hopefully this time we'll get a clean one. It's just going to start happening more and more. especially if Elon gets his wish and puts up 12 or 14,000 satellites or whatever he's talking for Starlink being. It's going to be virtually impossible to do almost any amateur astronomy, really. So that's not going to be so good. Let's see what else they have to say here. Talk about X-ray sources within the galaxy. It's estimated that M101 has about 150 globular clusters, which is the same as the number in ours. So, cool. Well, let's actually go into the Planetarium and see if we can't. Where are its companion galaxies? 5332 might be one. Let me undo the... Yeah, see, it's upside down, so the pulled away arm is at the bottom in this one. See, I think that is a galaxy down there. Let's change my display options here and turn off my filters. And you can see all of the galaxies that then show up. So that one that is in the image is NGC 5477, and then there's a whole bunch of other ones in here. Some of these may be a lot further away and may not be companions of the pinwheel, but probably some of them are. We have a whole stack down here too, and so these are probably, at least some of these are going to be the companions that are pulling it out of shape the way that's doing that. Put those back, otherwise I get an absolute swarm of stuff on my screen. That is not helpful. Pinwheel is a pretty one. Time for a drink. Yeah, that's coming out looking pretty good. Let me zoom in on it a little bit more even. Start to pick up some of the splits in the arms. And as we get more details, you can see these clumps in here. These kind of bluish clumps. And those are probably areas of star formation. High energy areas. They said it was 21 million light years away. Yeah, 21 million light years, and about 50%, 50 to 75% bigger than our own Milky Way. So it's a pretty big one. Yeah, it does look pretty good on the color. It's so big and bright that it's the color camera does a pretty good job with this. The outer wispy arms, the fainter stuff is where the mono would do better. It just has better contrast and a little bit better sensitivity. But on a big bright galaxy like this, or Triangulum, or certainly Andromeda, any of the bigger, brighter ones, the color camera does look nice because when they are this large and bright, you can actually see a bit of color in them. With the smaller ones, they're typically so far away that they don't do color. Very little color is actually transmitted when the light's traveling 50, 60, 80, 100 million light years. You just don't have a whole lot of color in them by the time it gets to us. But it does look nice on the color camera when it's this big. See how much of that arm we can pick up here in the next couple of minutes of sub-exposures. It's a pretty one. Yeah, mono cameras are great for doing, well, they're great for doing a lot of things. Astrophotographers have been using them for years because of their sensitivity, and then they just use filters on them to get the different wavelengths and then put it all together in post-processing. But that's way too much work for me and doesn't sound like fun. So I like them just for their higher sensitivity for doing the more monochrome type objects, which tend to be galaxies because of the distance that they are. So they are great for doing that, but for the stuff that's in our galaxy, the much closer stuff, the nebulae, even the star clusters that are pretty close to our galaxy, if not, well, certainly closer than a neighboring other galaxy is, but for the closer stuff, they tend to transmit a lot more color, so those look good with the color cameras. And at 21 million light years, this is honestly one of the closer galaxies to us. Pretty much in the local group. Well, there's 10 minutes on it, so that came out pretty well, I think. So let's go look at, I think M3 is next, which is another big globular cluster. So we will go look at that one. No, not you. You. M3. Go. Ooh. That's below the horizon. Oh. It picked up M33. That's not what we wanted. M3. Just 1 3. Okay. Interesting. Little hiccup there. Okay, anyway, there's our M3. And so right now we are up here, so this is just next door between the Big Dipper and Coma Berenices here. So let's go zip over to that guy. So this will be another case where we turn the exposure time down, because this is a real bright one. Okay, in fact we'll probably even go below. Let's start the imaging, and this time we're going to go We're gonna go low. We're gonna go low, low, low. Let me try 4 seconds, see what that does. Let's live stack you away, clear you up. See what 4 seconds gets us. Doink. A very black clipped cluster. Let's see what this does. Yeah. Definitely a bright one. It's a very dense one. So this is what most globs look like. M101, or excuse me, M67 was almost open cluster looking. It was so non-dense. But this is what globular clusters typically look like, and this is why they think they're possibly the cores of old galaxies, because they're just extremely densely packed clusters of stars. Let's see what. I know it's going to be one of the biggest ones. Okay. It was discovered in 1764. It was the first Messier object. It was the first Messier object discovered by Charles. Oh, okay. The third in his catalog, but the first one discovered. That's pretty cool. Okay. He originally mistook the object for a nebula without stars. The mistake was corrected after the stars were resolved by William Herschel around 1784, so about 20 years later. Since then it has become one of the best studied globs. Identification of the cluster's unusually large variable star population was begun in 1913, and new variable members continue to be identified up through 2004. Many amateur astronomers consider it one of the finest northern globular clusters, following only M13, which is the Great Hercules cluster. It has a parent magnitude of 6.2, making it a difficult naked eye target even with dark conditions. With a moderate sized telescope, the cluster is fully defined. It can be found by looking almost exactly halfway along the northwest line that would join Arcturus and Corcorola. Using a telescope with approximately a 10-inch aperture, the cluster has a bright core with a diameter of about 6 arc minutes and spans a total of double that. Well, we have better than that. But you can see how just really packed this thing is. And if I continue to reduce the stretch, you can see the outer stars disappear, but more of the central core now becomes visible. More of the stars in the core become visible now as I turn it way down. You can see how tightly packed these things are. And then as I turn it back up again, more of the outer stars become visible. The core gets blown out, but you see a lot more of the peripheral stars that are there. Definitely one of the grand globular clusters. What did I end up using? So this is a little under 4 seconds of exposure time. If you take longer exposure time, you get even more outside stars, but then the core just becomes this white hot blinding thing to look at. So just a few more seconds on this. We'll go to 5 minutes. That's more than enough for this big bright object, but it's a pretty cool one. Before we go though, let me do a color balance on it. Well, I can't actually, there's not enough data. So, but you can already see the different colors in the stars that are in there. Mixtures of the blues and the red, oranges, and yellows. Blue younger stars and the more orangey and yellowy older ones. Definitely a mix in there. One thing you can do with the color camera is see the different colors of the stars. So, that's a beauty. She's definitely a beauty. Just a very dense, a very intense large glob. Alright. So those were our easy objects. So now let's see what's next here. Alright. Yeah, that's the open cluster we did. Okay. So so Markarians. So a wide field deal here. So let's see how many we can fit in. 84, 86. Let's take a look. And I have done these recently. Why are you not going in there? I have done these recently as part of our galaxy quest. So you can see the whole chain in here. And you can see that my camera is not going to be able to do a whole lot of them. But we can try to center up as much as we can. Let's see if I do that. That'll get a few more. Yeah, it'll get quite a few. In fact, we got a few more down here, so let's actually drop that down and maybe do pick that star. And then we'll get some of the ones at the bottom here too. But this is a pretty intense cluster here. Yeah, there they all are. Ding, 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 ding. And there's a whole bunch down at the bottom. So, where am I? There we are. So 84, 86, and then this one here is 44, 35. 84, 86, and then 44, 35 will be there. Yeah. Okay. Let's see how many. This will be one of those opportunities where we see how many galaxies we can count in the image. But this is going to be quite a few in here. But there's going to be all kinds, you can see already, and there's all kinds of little tiny ones in there, so we'll be able to see quite a few. Ooh, that was a good sneeze. Good thing the mute button was close by. So now I'm going to have to go get a tissue, so we'll let a couple minutes of these build in, and I'll be right back. Wow, that's blinding. Yeah. We're going to need to fix that. There we go. Yeah, sorry you had to see a couple of minutes of that. But now it looks right. That needed to be a little bit more stretched. Now we can see a whole bunch of galaxies in here. Yeah, definitely a lot of smudges down here. A whole bunch of smudges in here. Oh, that's a nice little one. A nice shape to that. We'll take a closer look at that once we get a few more sub-exposures and get a little more detail. We'll zoom that satellite trail out of the picture. Yeah, M84 and 86. Just elliptical galaxies. But this NGC galaxy up here looks pretty interesting. Looks like it's pulled out of shape by a companion, probably this guy. Looks kind of distorted. NGC 4435. Looks like an interacting pair. And a whole ton of other galaxies down here. That's a pretty cool looking one. Definitely some sweepy curved little arms on that one. Very sharply defined. But quite a slew in here. 1, 2, 3 there. 4, 5, 6, 7. Possibly even 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think that's another smudge. A couple more up here, another one there. I think we got 20 plus. There's another one there. We're over 20 with this one. That looks like one there. And it looks... yeah, definitely smudgy and not star-like. The stars are always sharply defined. Oh, and there's another one there. It was out of what I had before, so we're probably close to 25 galaxies in this one shot. Each of them with billions of stars. Some of them possibly even with trillions. Hey Pete, how's life over in Utah? You guys warming up over there yet? We're hitting, well, we're definitely in the 90s now. We're starting to tip into triple digits more and more frequently. So summer is starting to move in here. I like the shape of this. So sharply defined, the arms in this galaxy. Looks like a barred spiral and some very sharply defined arms coming off it. You can kind of see the bar right across here. It just gets these bright lobes here on the edges. It kind of looks like a barred. Neat. But easily 25 galaxies in this one shot. So that's pretty cool. Just coming up on our 10th minute. So that's pretty fun. And there's a lot more in this chain it just keeps kind of going off and off and off here. Even M88 is out here, another galaxy. But we've looked at all of these things over the last few weeks, last month especially, when we did the galaxy quest through this area. So that was a lot of fun. Okay, next target. Let's see. Okay, so the medium challenge, Markarians, we definitely got. Yeah, I think we got a little bit better than what he pictured here. And see who did this. Oh, this is Pat. This is Pat, Utah. Nice little collection here, Pat. Thanks for doing it. Caldwell 40. Okay, so yeah, so C40 is an unbarred lenticular in Leo. I think we've done this. Well, probably. If it's in Leo, we probably have done it. So Leo, the lion, is over here with his head and his mane and his hind section there and body. And so Caldwell 40, let's see if, yeah, right up in there. So not too far away. Magnitude 11, surface brightness of about 12. Yeah, we should be able to see that. Yeah, right there in the middle. Okay, let's see. See what we can see. Unbarred lenticular. It was discovered by William Herschel in 1784. Well, they have it at Mag 10.6. Stellarium has it at Mag 11.2. That's not surprising. Different catalogs have that. Have different numbers. It belongs to the NGC 3607 group, some 70 million light years distant. So 50 million light years more distant than the pinwheel galaxy we were looking at earlier, which is why this one's going to be a lot smaller and fainter. but hopefully still something pretty interesting to see, even with the color camera. There we are. Definitely a little guy. We'll just have to see how much detail we can pull in. Let's see how much detail we can pull in the next couple minutes. I'm actually going to go snag another layer to put on. So, well, this is stacking a few more sub-exposures, so I'm going to be doing that. Be right back. Okay, that's better. Now, let's see. What's the NGC number on this? 3626. Let's see what Wikipedia has to say about 3626. NGC 3626. Actually, we can just go see what Pat said about it. Well, yeah, he didn't say a whole lot. No, that's basically all the information there is on it. About 70 million light years away, part of a galaxy group. And you can see clearly there's another galaxy there. But in this whole region of space, there's lots and lots of galaxies. All these red and orange circles are galaxies in here, and I have my filters turned on, so that's how many show up when I've got my filters off. on, and when I have them off, that's how many show up. And that's zoomed out. And you zoom in and even more show up. And I don't even have all the catalogs installed, so there are just so many galaxies. It's just absolute craziness. They now think that there's as many galaxies in the universe as there are stars in the Milky Way, which is hundreds of billions. So we're still figuring out how many there are. And probably will be for quite some time. But let's go back to our picture. There we go. Yeah, starting to see a little bit of a maybe a little arm there, perhaps. Hard to tell. Something a little looks like a little shape of some kind. Definitely a bright ovally core. Resolving any more detail, though. Can't tell if the detail's improving or getting worse. I think it's improving a little bit. When I look at the live stream feed, it actually is a little more clear. Let's check our... Yeah, this all looks pretty good. Good as we're gonna get it with the color camera. Definitely a little guy. There's 10 minutes. 10 minutes of as good as we're gonna get it. So definitely it's an interesting one. A couple other galaxies in the image too. Coolies. Alright. Let's see what Pat has for us next. Ras Elast So this is a star. Okay. Let's... Oh, okay. It's a star in Leo. It's the eye star, maybe? Star at the top of his head. Well, let's take a look. I don't do much star viewing, actually. So, this could be a little interesting. Whoops. Wrong button. Duh. Definitely a bright star. Let's zoom out. How are we doing for center here? Yeah, we're a little off. Let's bring ourselves back into a little bit better center here. There we go. That's probably about good enough. Okay. Wrong button. Okay. So if we center on this now, so this is a star. Now this is interesting. A star. Now usually we don't want to do too much more with the stars. Are so bright that you don't really even need to do any stacking with them. So I'm not even sure what to do with this. Let's just try turning the gain down so we're a bit less grainy. That might be a bit much. Okay, so this star is 124 light years. It's 1.5 times the sun's mass, but has expanded to around 14 times the sun's radius. So it's pretty darn big. It shines with 63 times the luminosity of the sun. Very bright. It's around 3.3 billion years old. And an exoplanet was discovered around it. Wow, it's at least it's about 2.5 times as massive as Jupiter. Wow. That's pretty amazing. Not sure that there's much spectacular for us to look at, though. So, probably not going to spend a lot of time on that, but interesting story, though. 2.5 times, the exoplanet is 2.5 times the size of Jupiter, which I believe is 30 times the size of Earth, if I remember correctly. So that's a pretty dang big deal. Oh, Pete, we bought a house in Las Vegas. Wow, really cool. We're watching from down here now. We will be going back and forth for now. Hope to get out to Tacoma before it gets real hot. Yeah, you better not wait too long. We're starting to hit triple digits. The bombers are out. The bombers are very large horseflies here that will bite right through denim. So they're a summer how do we say that? Feature? Not bug, but feature. They're just an interesting aspect of living out here. Alright, well, I'm not sure we need to spend a lot of time on that. So, Abell 21 is the Medusa Nebula. It's a planetary nebula in Gemini. Okay, Abell 21. Abell. Whoa, what happened? Wow. I have no idea what I just did. I have a feeling that's just doing crazy stuff on the... Yeah, it is. Let's go to today, please. Thank you. Yeah, I think it was... this is moving the time forward really fast. That's what that was doing. Okay, so F3. Nope, F3. For some reason the Abel 21? Nope, it's not going to be that one. What did I do wrong? Abel 21. The Medusa Nebula. Well, that's Pegasus, so that's not even Gemini. Okay, so let's try the Medusa Galaxy. Medusa Galaxy. Well, that's certainly a lot better. I don't see it as Abel 21. Whatever. Okay. Back up once again to upside down land. And right underneath the bucket of the handle and bucket of the Big Dipper. And I forgot to do this part. Next target 533. Ooh. Well, I guess it could be this one. I suppose it could be. Let's see if we have anything. That's not terribly promising. Magnitude 13.3. That's pretty faint. Well, I'm going to assume it's in this view because we didn't move that far. So I'm going to assume it's in there. Somewhere it's in this image. Abel 21, also known as the Medusa Nebula, is a planetary nebula in the constellation Gemini, originally discovered in 1955 by UCLA astronomer George O. Abel, who classified it as an old planetary nebula some 1,500 light years away. As the nebula is so large, its surface brightness is very low, with surface magnitudes 16 to 20? Whoa. Okay, well, may be challenged to get this one. May be challenged to get this one. I'm certainly not seeing much of anything in here. Well, let me look on Wikipedia here and see if I can get the catalog number of this. 4194. NGC 4194. NGC 4194. Doink. Okay. No, that's not it. Medusa Nebula. NGC 4194 The Medusa Merger is a pair of interacting galaxies in the constellation of Ursa Major. Well, this could be it. No, this can't be it. Yeah, this can't be it. The Medusa Nebula is a planetary in the constellation of Gemini. Okay, and that's why this is why we're getting confused here, because this is these are the Medusa. This is the Medusa galaxy, which is not what we are supposed to be imaging. So we need to do this again. We're supposed to be in Gemini. So that means I need to back up and start over. So this one, I'm in the wrong place. I'm on the Medusa galaxy, not the Medusa Nebula. Okay, let's try let's go back to here. Let's try the search again. Medusa galaxy, Medusa Nebula. Okay, this should probably come out a little bit better. Alright. Ooh, 22 degrees. Ooh. Ow! I hate it when I catch the cord on my microphone. You know what? I don't think we're going to be able to see this. This is at 22 degrees. Yeah. Nope. It's right on the side of a building. So we're not going to be able to see this at all. Darn. I wish I had known an hour ago that this was something that was needed to be done first. We would have done this one first. Of course, in the western sky, as this is, it would have been... Okay, well, we're not going to get to do that one. That one is not going to happen. Okay, well, gosh, does anybody have any requests? Because we are fresh out here. What we got here? C25, Intergalactic Wanderer. Another globular cluster. We can just pop up onto that. That should be high enough to see, I think. Yeah, that should be. Yeah, there it is right there. Let's see. Again, 60 seconds might be a little too much for this. As a glob, it's pretty bright, so we'll drop it down to 30. And you just crapped out, so we will drop it down to 30 and see what we can see. But yeah, if anybody's got a got any requests, let me know. That's the Owl Nebula. We've done that a couple times. We just did that last time, in fact. Oh, in fact, wait, this is M13. This is actually, we've done M3, which is the second biggest. M13 is actually the biggest and brightest. So we could actually just do that one next. Compare that to the M3 we already did earlier. Because Hercules is up in the eastern sky. Yeah, there's that intergalactic wanderer. Probably a histogram adjustment is a bit needed here. Yeah, definitely a little glob in there. Caldwell 25. How far away? Oh, I've already gone beyond that, so we'll just do this one. Caldwell, no, come on. Caldwell 25. This was discovered by William Herschel in 1788. It's a distance of about 300 light years from the solar system. Yeah. So this is well above the galactic plane and outside of our galaxy. As most globular clusters are, this one's 300,000 light years away, which is about 3 times the diameter of the Milky Way itself. So it's one of our satellites. 2419 bears the nickname the Intergalactic Wanderer, which was bestowed when it was erroneously thought to not be on orbit around the Milky Way. Its orbit takes it further away from the galactic center than the Magellanic Clouds, but it can be considered as part of the Milky Way. At this great distance, it takes 3 billion years to make one trip around the Milky Way. 3 billion years. So basically, in the entire history of the Earth, it's made 1.5 orbits. So that does take a minute. Thousand light years away. The cluster is dim in comparison to the more famous globs such as M13, which we are going to look at next. But you can view it with good quality telescopes, as small as 4 inches in aperture. Intrinsically is one of the brightest and most massive globular clusters of our galaxy, having an absolute magnitude of -9 and being 900,000 times more massive than our Sun. Coolies. Well, let's go look at M13. So you can see the relative size of that to the star field behind us, and the field of view of the of the camera itself. And now we'll go to M13. M13 is one of the biggest and most spectacular ones in the sky. So this will definitely be big and bright. There it is. Big fuzzball. Okay. I don't even need to do much with it at all. I don't even need a stack to see most of that. It's quite the thing. Okay, well, we'll do it anyway. Start imaging. And let's drop the exposure down. Now we were at the full 60 seconds with the Galactic Wanderer. This one we're just going to do it 4 seconds. Of course it's... It's this, so there's the same frame that we had at the last one. So this is how much bigger and brighter it is, and it's actually still not even. That's about the full extent of it there. Just back this off a little until we, because it's quite so much of the outside. This is definitely another big bright beauty like M3. I think this one's just a little bit bigger. And 13. Globular cluster in Hercules, or the Hercules globular cluster. It's several 100,000 stars. Just cataloged by Charles Messier 50 years later. About 1/3 of the way from Arcturus, Vega to Arcturus, 4 bright stars in Hercules form the keystone asterism. Yeah. Although only telescopes with great light-gathering capability fully resolve the stars of the cluster, M13 may be visible to the telescope. May be visible to the naked eye depending on circumstances. With a low-power telescope, M13 looks like a comet or a fuzzy patch. The cluster is visible throughout the year from latitudes greater than 36 degrees north, with the longest visibility during Northern Hemisphere spring and summer. Right. Now, I am right about at 36 degrees here. So for me this does drop below the mountains to that I have on my horizon, so I cannot call it circumpolar, but if you live northern more farther north than me, you can. It would actually stay above the horizon as the sky rotates around the northern celestial pole. Nearby is NGC 206207, a 12th magnitude edge-on galaxy that lies 28 arc minutes directly northeast. Do we see any other galaxies in this image? Oh, we do. We sure do. It's kind of a cool little one, even. Although to see this, I would definitely want to increase my exposure time. This is such a big, huge, bright object. And the galaxy, obviously, it would be a very small, faint one. So, when you have the exposures set up correctly to get one, you're definitely not going to be able to see the other very well. In this case, we can't see the galaxy very well, and if I increase the exposure to see the galaxy, the globular cluster would be completely blown out. But yeah, there definitely is a galaxy up there. I don't see any other ones in the picture, but that definitely is is one up there. But M13 is a very big, bright, and cool asterism. What else could we look at that's fun? Snow globe cluster, more globs, back to M3 of course where we started, and 53 another good one, not as big and spectacular as 3 or 13 but a good one nonetheless. Let's see, that's the Owl Nebula up there. I know we looked at that just, in fact, I think last week. No, come on. What are these? These are pretty low. Southern Sky. Maybe, what are you? Not much. Rise size. Couple of planetary nebulas. Well, we could try going and looking at those. What the heck? That's pretty all we need for M13 anyway, so that's pretty bright, spectacular globular cluster. Let's go see if we can see. Let's go see if we can see these other planets. We didn't get to see Abell 21, or what he called Abell 21. I don't think it is Abell 21. But we didn't get to see those, so let's see if we can see these. Yeah, 30 degrees. Almost dead due south. We should be able to get in on those. Let's do a plate solve. Kick it up to 4 seconds and do a plate solve. I haven't used the plate solver in a while. See how that goes. Looks like my internet is going wonky again right now, so apologize for that. There we go. About a third of a degree off. Well, let's just start the stack and see what comes up. And it definitely looks like my internet is going wacko. So, may have some buffering experienced at your end. Apologize for that. can see anything. Surface brightness of 15, that's going to be pretty dim. So we might not see much. Worth a shot. Oh yes, and then we've got to set the histogram back because I was doing a short exposure there. Oh yeah. I have to crank up the stretch so you guys can see it, but yeah, right there. It's definitely there. Well, this will be interesting to see. See what this turns into with some sub-exposures piled on here. Looks like my internet has stabilized for the moment. Oh, I should have knocked on wood. Definitely something there. Very faint guy, though. Very faint. But with a surface brightness of mag 15, that's about right. But I think we'll be able to pull in some detail with this once we get a few sub-exposures stacked on. Definitely a shape there. Starting to even get a little detail in it. Try stretching it a little bit more. Darkening it up. And stretching it a little bit harder. Let me do a color balance on it too, just for gits and shiggles. Yeah, you can definitely see something there, though. Nice round shape here, a little bit of a pocket up here. It's kind of poofed out of it. Definitely very faint. Might not get a lot more out of this. How bright is the other one? Yeah, see, with a surface brightness of 15, mag 15, that's a pretty dim object. What does this one got? That's another one. Mag 15. Probably won't bother with them too much. In fact, I'm kind of ready for an early night anyway, so this will probably just be the last object. I'll call it an early night. But we'll try giving it its full 10 minutes. We are getting some more signal-to-noise ratio out of it. Definitely is. Got almost 2 circles in here. Internet's still doing wacky things, so apologize for the buffering. Well, coming up on our 10th minute here, which means probably not going to get a whole lot more out of it than that. It's very faint, but definitely a nice planetary nebula shape. And the central star there is probably the core star of that's creating it. It could be one of the dimmer ones back here. Planetary nebulas are stars that have blown off their outer layers, nearing the end of their life. Which this is probably what will happen to our own sun. And when they blow off those outer layers, the central core still continues to burn, and it illuminates the gases as they expand outward from the original location of the star. So they're neat objects, but most of them are either very small or faint or both. There are a small handful that are nice and bright, but mostly they're just pretty small and intense. Small and intensely dim, yes, I should say. But anyway, that is that one. But I think I am going to call it a night. Thanks everyone for being here, and hope you enjoyed yourself. It was a nice evening, and I'm just a little tired. We got through our list of things, so I'm going to call it a night. So thanks everyone for joining, and I'll see you next time, probably even soon, because it looks like the weather's nice. So maybe in the next couple, 3 nights, if the weather forecast holds, we'll do another one. So thanks everybody, and good night.